Hello everybody. In this video we are going to study about Prim's algorithm for minimum spanning tree and we are going to try and solve it. So what is Prim's algorithm? We have already talked about minimum spanning tree in one of my previous videos. So let's talk about the salient features of Prim's algorithm. Prim's algorithms require a starting node, that is we choose a starting node. After that we select an edge with the smallest weight. Then when we have selected the smallest weighted edge, it connects two nodes. So from those two nodes you can further select any one of the smallest weighted edges and keep on doing that until all the graph is traversed into a minimum spanning tree. What you need to be careful about is that you don't need to select an edge which makes a cycle, right? And we need to keep on going there until all the nodes are traversed. Prim's algorithm only works for a connected graph. It does not work on a disconnected graph. So in this particular example, you can see a connected graph. Let's traverse that using Prim's algorithm. First of all, our starting node that we have selected is A. So the first minimum edge that we have connected to A is A to B. We select A to B. Then we have two choices, A to H and B to C. We can choose either one. So let's choose B to C. Now our choices have expanded and we can even see the smallest. We can also select the weightage edges that are connected to C, and we can see that Ci has the smallest weight, that is 2. So we select Ci. After that, the least weighted edge is Cf. Then the least weighted edge is Fg. Now the least weighted edge is Gh. Right? Now what do? The minimum value that we have is 6. The minimum weighted edge we have right now connected to any traversed node is 6, but we cannot select 6. Why? Because it makes a cycle, and that we cannot make a cycle. That is one of the Prim's salient feature of Prim's algorithm. We cannot make a cycle. Okay. What about Hi? The value greater than 6 is 7, but Hi also makes a cycle. We can't select that over here, but we can select CD. We can select CD, which is also 7. So let's select that. Right. After 7, we have the value 8, which is AH. We cannot select AH. Why? Because it will make a cycle. And according to the salient feature of Prim's algorithm, we cannot make a cycle. Moving forward, we have the edge DE. DE is weight 9. We can select that. After that, weight 10 is EF. Can we select that? No. We cannot select that. What about 11? PH? We cannot select that. It will also make a cycle. And similarly, DF. We cannot select the edge because it will also make a cycle. So, in short, we can say that by using Prim's algorithm, we have created a spanning tree and traversed the entire graph. Now, let's look at it closely and see if it follows the rule of the minimum spanning tree, that is, the number of edges is one less than the total number of nodes. So, what are the total number of nodes? 9. What are the total number of edges? 8. Yes, it does follow the minimum spanning tree rule where the edges need to be one less than the total number of nodes. And summing up all of the weights of the minimum spanning tree, we get the total weight as 37. If we want to redraw this, we can see that this after applying Prim's algorithm, the graph is converted into the spanning tree. This spanning tree can also be redrawn in the, as you can see on the left side, you can draw it in the tree format, or you can just keep it like that, whichever way you like it. This is just a representation of it. Thank you very much. Kindly subscribe the video and I hope you like it. Kindly click like too. Thank you very much.